Hello children, I am again here with second part of the chapter element, compound and mixture. And in the first part we have discussed what are element, compounds and mixture and differentiate between compound and mixture, that we have done. Here we will do separation of components of a mixture. Components means how many parts a mixture must have. Okay. First method is hand picking, and the principle of this method is when the components of a mixture in which constituents have different colors or different size. Okay, suppose this is a mixture of pink and blue balls. Okay, so if you have to collect only pink ball, you can identify it by its color. So you will collect only pink balls. Okay, so you will use your hand for separating these pink balls. And suppose it is asked that collect the biggest ball from this mixture, so you will collect these two balls only. Like this, if it is based on color or size, then you can use hand picking for separating the constituents. Second method is magnetic separation, and the principle of this method is in a given mixture, one component must have magnetic property. Okay, one component must have magnetic property, or it may be iron also. So then that in that type of mixture we will use magnetic separation. Here we use magnet for separating out iron particles. Like we have done in the previous topic mixture, that it is a mixture of iron filling and sulfur. When we have to separate iron from this mixture, what we are doing, we are using magnet over here. So magnet will attract all the iron particles and now only sulfur will left. So like this you can separate iron from any mixture in which magnetic substance is present. So the example for magnetic separation is iron filling or iron and sulfur. Okay. Now next method is gravity separation. Principle of this method is that in a given mixture, one component is much lighter in weight, okay, much lighter than other. Suppose we are taking a mixture of sawdust, sand and water. You will see that the sand is the lightest one among these two. So you can use gravity separation here, okay. The lightest particle will float at the top of the mixture and the heavier particle will settle at the bottom of the mixture. See here, sand is settle at the bottom because it is heavier among these two, heaviest, and it will be attracted by gravitational pull. That's why it is settle at the bottom. And sawdust are very fine particles. These are that much small particle and lighter particle that gravity will not be able to pull it down. Okay, so this sawdust will float on the top of the mixture and heavier particle will settle at the bottom of the mixture and water will be in the between of these two. Okay, so this is based on gravity only. Which one is heavier, that will come at the bottom, which one is the lightest, that will float on the top. Next method is sublimation. The principle for this method is in a given mixture, one component must be able to sublime easily. Okay, sublime easily, or that can undergo sublimation. Now what is sublimation? That you all know that when a solid is directly converted to gaseous state on heating, and on cooling gas is directly converted to solid state without passing through liquid state. Okay, solid to gas and gas to solid. Okay, so this is sublimation. Now you have to learn some examples. Okay, here is camphor, iodine, ammonium chloride, dry ice, naphthalene balls. 5 examples are there: 1, 2, 3, 4 and 5. In your syllabus, the mixture must contain these only. These 5 must be present in the mixture. So if any of these 5 is present in the mixture, you can easily say the components can be separated by sublimation process. let's take one example of common salt and ammonium chloride. So here ammonium chloride is present. So what I said, if any one of these five is present in the mixture, you will write sublimation process. Okay. So ammonium chloride is present here. So the separation technique must be sublimation. Now let's see how separation of ammonium chloride and common salt can be separated. So we have taken a china dish. In that china dish, a mixture of ammonium chloride and common salt is taken, and it is heated from the bottom of this china dish. Okay, and over it wire gauze is there so that heat can evenly distributed. Okay, and one inverted funnel is there just above the china dish, and on the top of this inverted funnel cotton wool is there. This is here to stop the escaping out of vapors. Okay, so now if the mixture is heated strongly, then you will see that some vapors are forming here. These vapors are of ammonium chloride. What I said, it will convert from solid to gaseous state on heating. Now when this vapor comes in the contact of this inverted funnel, that one is not that much hot, so it will get deposited over this funnel, and on cooling it will again come in the form of ammonium chloride. Okay, so again what is happening here, it is getting in the solid state. See, one more time I am explaining you. Ammonium chloride and common salt mixture is there. On heating, ammonium chloride is sublimable substance, so it will form vapors, and when it come in the contact of funnel, it will cool down and deposited on the surface of funnel. Okay, that means it is again converted back into solid state. This cotton is here to stop the escaping out of vapors of ammonium chloride. Okay children, now I think it is clear to you. If you have any doubt, you can ask in the comment section. Next method is by solvent extraction. Okay, so the principle for this method is we will use a suitable solvent for one component, whatever component is present in the mixture. For one component we will use a suitable solvent in which that component can dissolve easily. Okay, can dissolve easily and other components cannot. Okay, let us take one example of charcoal and sulfur. Wherever sulfur is there, children, you will use a solvent CS2. CS2 is carbon disulfide. Carbon disulfide is the solvent in which sulfur can dissolve but charcoal cannot. Charcoal cannot and sulfur will dissolve. So what we will do next? We will do filtration, and the residue will be charcoal and filtrate will be a mixture of sulfur and CS2, and then we will do evaporation so that we can collect sulfur and CS2 will get evaporated. Okay, so these steps we have to follow. Now let us see one table for in which a substance is given, and for that substance a suitable solvent is given. Sulfur we have discussed just now, carbon disulfide, phosphorus, again carbon disulfide, paraffin wax, turpentine oil, rubber, benzene, chlorophyll, methylated spirit, oil, petrol, nail polish. Acetone is the solvent that you can use at your home also. Glue, ethyl alcohol, rust, oxalic acid, and nitrate is water solvent. Okay, so these are the solvent in which these 10 substances can easily dissolve in these 10 solvents. Okay, so keep this in your mind so that it will be easier for you to separate the components. Next method is sedimentation, decantation. Okay, you have done this before so many times. Sedimentation is one component must be heavier and one component must be lighter. So what we do, we will take a mixture of muddy water and we will leave it undisturbed for few minutes. Okay, after some time you will see that the heavier one is settled at the bottom of the beaker and lighter is on the top of the sand. Okay, see here the heavier substance, like here it is mud which is settled at the bottom, that is called sediment, okay, or the liquid is supernatant, okay. So these are the terms: sediment that will settle at the bottom, or supernatant that will occupy the upper layer. Now how you will separate them now? So we will do decantation. We will take this beaker and we will, without disturbing it, we will pour the top layer through a glass rod, and it will be separated like this, okay. We will pour very slowly only water, okay. This process of pouring water only is called decantation, okay. And now this process, here the funnel is present, and in that funnel one filter paper is there. So this process is called filtration, okay. Sedimentation is settling down of heavier substance at the bottom, okay. And decantation is to remove the top layer without disturbing the bottom layer, and the top layer is slowly removed from the sediment, okay. Till here only it is sedimentation. Children, don't take this one, okay. This one is filtration, it is not decantation. Now next is filtration. This is the filtration process, okay. What we are taking, insoluble residue present in a mixture, okay. One component must be solid and another must be liquid, okay. So when solid liquid mixture is there in which solid is insoluble, then only you will do filtration. If solid is soluble, then you will not be able to do filtration, okay. Insoluble solid present in liquid, then only you will do filtration. What we are doing, we are taking a mixture of insoluble solid and water. Through the glass rod we pour this mixture on this filter paper that is in cone shape, and this is funnel which is here holding that filter paper, okay. And when mixture is poured slowly on this filter paper, you will see that only water can pass through this filter paper, because filter paper has very small membrane or very small pores which allow only water to pass through it, okay. And the bigger molecules, bigger components like insoluble solid will settle on the filter paper, and this is called residue, which is collected over filter paper is called residue. And what we are collecting in the beaker through the filter paper is filtrate, okay. Filtrate is the solution which is collected after passing through the filter paper, and the residue is that solid, insoluble solid, which is collected over the filter paper, okay. One more example is that we prepare tea at your home. So what we do, we take strainer, and on that strainer what will we see that tea leaves get collected over the strainer, and the water or tea comes out in the cup. So the cup contain filtrate, and tea leaves which is collected over strainer is residue. So this whole process is called filtration. It is done for that mixture only in which solid is insoluble in liquid. Next method is evaporation. The principle of this method is that one component is in solid state which is soluble in water, and it is non-volatile, okay. That solid is soluble in water, and it must be non-volatile. Non-volatile means what, children? Non-volatile means it will not form vapor. Non-volatile means it will not form vapors, okay. So it is dissolved in water, but it is not forming vapor when it is heated, okay. And other is liquid, okay. What we will do, we will take the mixture of common salt and water and we will heat them together. What we will see, that common salt is left behind and water is evaporated. Now see how evaporation takes place. The mixture of common salt and water is taken in a china dish, and this china dish is placed over a sand bath. Sand bath means it is a dish in which sand is taken, and on that sand china dish is kept. Okay, and we are heating this sand bath from the bottom of this sand bath tub, and what we can see here, common salt which is soluble in water, which it will left behind here. Only water is forming its vapor. Okay, because common salt is non-volatile and it is soluble in water, that's why it is a mixture, a homogeneous mixture. Okay, what you will see, you will see that after some time water, all the water molecules has been evaporated and only common salt is left behind in this china dish. So like that you can separate the mixture of common salt and water. Now next method is distillation. The principle for this process is the liquid component of the mixture gets evaporated and converted into pure liquid on cooling. Okay, in evaporation the liquid is getting evaporated only. Here the liquid is converted into pure liquid also. Okay, on cooling, whereas the solid that is soluble in the liquid left behind, and that solid is non-volatile. Okay, non-volatile just now I have explained, that will not convert it into vapor. Okay, so we will take example of sodium chloride and water that is also not pure. Okay, so when these two are mixed together and we will do distillation, we will get pure form of water, and sodium chloride will left behind in that apparatus only. Okay, now see, the apparatus arrangement for distillation process is like this. A round bottom flask is taken. In that flask the solution, salt solution, that is sodium chloride and water is taken in this flask. Round bottom, this its name is round bottom flask, and here it is beaker which is heating that round bottom flask. One thermometer is placed on the top of this flask, and this is called Liebig's condenser. Okay, this is called Liebig's condenser. Children, remember the name of the condenser, it is very important. Okay, it is important for your exam also. So remember these names, Liebig condenser, and in that condenser you will see that outlet for water is there. Okay, and one inlet is also there. For cold water it is inlet, and outlet for water it is there. And that condenser is connected with a conical flask. This is called conical flask because it is in the shape of a cone, okay, or triangle. That's why it is conical flask. Now see what is taking place inside that mixture. This process is distillation. Okay, salt solution is taken in a round bottom flask. It is heated. Okay, after heating to some low temperature, the vapor of water will form here. And because solid is non-volatile solid, so it will not form vapors, only water will form vapor, and it will pass through this condenser. One pipe is also inside that condenser, which is passing through the condenser. Okay, condenser contain cold water in it, and here what is going through the pipe, that is water vapor. So water vapor is collected through the tube which is inserted in condenser, and when it reaches here the water vapor will convert into liquid state. Okay, because the condenser has cold water in it, so vapor will get cooled down and condensation process will take place. That's why water vapor will be converted into liquid. And now this is the purest form of the liquid which is taken here. Okay, or you can say this is distilled water. It is pure water which is collected over here. After some time you will see that sodium chloride is left here in the bottom of the flask, and all the water is converted into distilled water. Okay, so this whole process is called distillation. And evaporation, what we have done, we have just evaporated water and collected solid over here. We have not collected the pure form of water in any apparatus. Next method is used to separate liquid mixture. Okay, That means both components are present in liquid state. So what we will do, we will use here separating funnel. Okay, we will use separation technique, that is separating funnel. Now what is separating funnel? It is a glass tube that is shown in the picture, glass tube, and at the bottom of the tube there is one stop tap is there. Okay, one tap is fitted at the bottom of the tube. This tap will control the flow of liquid. Now see the method. This method is used for the separation of liquids which are immiscible. Immiscible means they will not mixed with each other. There will be separate boundaries. That means these are heterogeneous mixture. Okay. Put the mixture in a separating funnel. Allow it to stand for some time. The heavier liquid forms the lower layers, whereas the lighter liquid forms the upper layer. Okay, the heavier liquid will take at the bottom place and lighter will come over it. These layers can be collected in separate beakers. Okay, some examples are oil and water. Which one is denser? Water. If it is in less quantity, then water will be lower or denser. So it will take lower layer and oil will be the lighter. If it is in small quantity, then oil will be upper layer. For chloroform and water, chloroform is denser, so it will take lower layer and water will be upper layer. Next, mercury and water. Mercury will be heavier, so it will take lower layer and water is on the top of mercury. Now let's see how it will get separated. Now let's take one example of oil and water. Okay, suppose oil is in the less quantity and water is in the more quantity. So oil will be lighter, it will be on the top layer, and water is at the bottom because it is in more quantity. Okay, so water will be at the bottom, oil will be on the top. Now both are immiscible liquid. You can see separate boundary is there. You can easily identify from where oil is taking place in the tube and from where water is taking place in the tube. Now this is heterogeneous mixture. Okay, immiscible and heterogeneous. Now what we will do? We will take a beaker at the bottom of the tube. Okay, and we will open this tap over here. Okay, so what you will see, water will flow slowly down and it is collected inside the beaker. Okay, and when this layer will reach till here, we will again close the tap. Now we will take another beaker and again we will slowly open the tap and we will collect oil from the separating funnel. Okay, so like this we can easily collect both the component which is present in the liquid. Okay, first component will come first, which is at the lower layer, and second component will come next when this is removed. Okay, so like this we can separate immiscible liquids. Next method is fractional distillation. Okay, in this the mixture of miscible liquid is taken. Miscible means they will mixed with each other and they will form a homogeneous mixture. Okay, here it is homogeneous mixture. For separating funnel, that is heterogeneous mixture. Okay, liquid mixture is miscible and they can be separated by fractional distillation. Principle for this method is that liquid must be of different boiling point. Okay, so the boiling point of the liquid present in the mixture must be different. Examples are ethyl alcohol, 78 degrees Celsius is boiling point, and water, that is 100 degrees Celsius. Okay, again methyl alcohol and acetone, the boiling point is 64.5 and 56.5. So here also the boiling point is different. So we will use fractional distillation for the separation of the component, these each component. Okay. Now see here, fractional distillation, the apparatus arrangement is like this. In the conic round bottom flask, the mixture of ethyl alcohol and water is taken. Okay, so when we will heat the mixture, first we will reach at 78 degrees Celsius, that is for ethyl alcohol. So at that temperature, the vapor of ethyl alcohol will collected in the fractionating column, okay, and then it will pass through the tube, and again Liebig's condenser is used here, and it will cool down the ethyl alcohol vapors, and again it will form in the pure liquid. That means the liquid collected over here is pure ethyl alcohol in which no water molecule is present. Now whatever is left, we will again heat the mixture till 100 degrees Celsius, and that 100 degrees Celsius is for water. So the water vapor will get evaporated, and through the fractionating column it will pass through the tube, and then it will cool down here and converted into liquid state, and that is the pure form of water. Okay, so fractional distillation is used for miscible liquids having different boiling points, so that you can heat at lower temperature. The lower boiling point liquid will get evaporated and collected in the form of pure liquid, and at higher temperature the next liquid which is present in the mixture will get evaporated and vapor will get condensed and it will give pure liquid. So like this fractional distillation take place. Now next, separation of liquid gas mixture. Okay, till now we have done liquid solid, liquid liquid, and next is liquid gas mixture. So a mixture of gas and liquid can be separated by simple heating. What happens here? When we it is based on the principle of solubility of gas in a liquid, okay, and it will decreases with increase in temperature. When we will heat the liquid, what will happen? The kinetic energy of liquid will get increased and it will start moving, and due to this movement the gas will escape out from the solution and the liquid solvent is left in the container. Okay, like this it will take place. Now let's see the apparatus arrangement for the removal of anhydrous calcium chloride to the gas. Okay, we have to take the mixture in this round bottom flask. See here, round bottom flask is there, and suppose it is a mixture of carbon dioxide and water. Okay, we will take here carbon dioxide and water or soda water. When we will start heating it, what will happen? The kinetic energy of water molecules and gaseous molecule will increase, and after some time you will see that bubbles are forming out. Okay, these bubbles are due to the gas molecule which is present in the liquid. Okay, and these gas bubbles in the soda water, carbon dioxide gas is present, so this gas will pass through this tube, and one drying agent is there. That drying agent is anhydrous calcium chloride. Okay, it is used here to dry the gas. When carbon dioxide is passing through this anhydrous calcium chloride will absorb some moisture if they have through it, and again it will pass carbon dioxide, and now the carbon dioxide gas is collected in this empty jar. Okay, so here all the carbon dioxide gas is collected which is present in the mixture. One more time I am explaining you. Here we are taking anhydrous calcium chloride. It is used to dry the gas, or it is used as drying agent. What we are doing? We are heating the mixture of soda water. Soda water means it is a mixture of water and carbon dioxide. After some time you will see the bubbles of carbon dioxide, and the gas will pass through the tube into through the anhydrous calcium chloride which is used to dry the gas. Why we need to dry the gas? Because on heating some water vapor also come into this tube. Okay, to remove that water molecule we are using anhydrous calcium chloride as drying agent. Now all the water molecule is absorbed by calcium chloride, only carbon dioxide is passing through it and it is collected in the jar. Like this you can separate a gas from a liquid. Now children, see here, one systematic scheme is there in which we have taken one example of mixture in which components are common salt, iodine and sulfur. what I have said, whenever sulfur is present in the mixture, what solvent we will use? We will use carbon disulfide. Okay, so we will dissolve this mixture into carbon disulfide. Only sulfur will get dissolved, and this is collected as filtrate. Okay, sulfur plus carbon disulfide is collected as filtrate. What is collected as residue? Iodine and common salt. Okay, iodine is sublimable substance, so we will do sublimation. The vapor of iron will get collected on the inverted funnel, and on the china dish what is left? Common salt. Okay, residue is common salt and sublimate is iodine. Now here we have to separate sulfur from carbon disulfide mixture, so we will do evaporation. After doing evaporation, CS2 get evaporated and only sulfur crystals will be left behind in the china dish. Okay, like this you have to do the classification in the chart form. Okay, and you have to separate the components of mixture. I will give you some assignment based on this. You have to do that, and if you have any doubt, query, you can ask in your comment section.